Hello and welcome to today's webcast brought to you by Compliance Week, Revenera, and Bitsea. I'm Kyle Brasser with Compliance Week and I'll be your host. Today's webcast is getting real about the license complexity of Linux. Before we hear from our presenters, let me review the agenda. We're scheduled to go for 1 hour. After the presentation, we will have a question and answer session. Your questions will be kept confidential and anonymous, so please don't be shy. You can ask your questions at any time using the Ask a Question function on the left-hand side of your screen, and I'll pose them to our guests at the end of their presentation. After the Q&A, I'll wrap up the webcast. This webcast will also offer CPE credit for all attendees. Please be sure you are using either Google Chrome or Firefox as your internet browser and that you have disabled your pop-up blockers in order to ensure access to the exam. Once I have signed off and the webcast is completely over, the final examination will be presented automatically in a separate window. If you have trouble viewing the CPE test or receiving the CPE certificate, please send an email to webcast@complianceweek.com. Once again, to ensure receipt of your CPE credit, please use either Google Chrome or Firefox as your internet browser. If you've missed anything, I'll repeat these instructions at the end of the webcast, so stay tuned. A few other administrative details. At any time during the presentation, listeners can download the slides from the drop-down menu on the left-hand side of your screen. There you will also find the feedback form for the webcast. We welcome your thoughts as we are always looking to improve your experience. If you wish to increase the slide size, you can also hit the View Slide Full Screen button at the top right of your screen. And lastly, a help button is located in the upper right-hand corner of your screen for assistance. I'd like to welcome today's speakers. It is my pleasure to introduce Andreas Kotulla, founder and managing director at Bitsea. Bitsea is a high-tech startup founded in 2008 near Cologne. Bitsea analyzes, evaluates, and optimizes software development processes, software architecture, and software design to ensure the future viability of software products. Dr. Kotulla has been active in the IT industry since 1995. We also have Michael Lelchuk, manager of professional services at Revenera. He has worked in the software composition analysis space for over 13 years, managing audit projects before moving on to his current role of managing the global audit services team at Revenera. It's great to have you all with us, and with that, I will turn it over to Andreas to get us started.
Thank you, Kyle, for the introduction. Good afternoon, everybody. My name is Andreas Kotulla, and I'm the Managing Director of Bitsea, and I will present you some of the very interesting findings of our recent audits today. First, I will have a short introduction of Bitsea and the services we offer. Then you will get some background on open source usage, its advantages and risks, and I will explain what software composition analysis is. Then we will come to the key area, Linux and its licensing mechanism. Linux is a great system which is widely used, and a big part of it are licensed under the GPL. However, there are many exceptions and other copyrights, and users need to adhere to all these different obligations. The Linux Foundation therefore initiated a license cleanup activity and tried to make identification of licenses easier for each file. However, with this partly automated approach, some of the items slipped through and were only rectified much later. Bitsea was founded in 2008, and our headquarters is located south of Cologne in Germany. Bitsea helps customers to analyze, assess, and optimize software development and development processes. We audit software systems, and Bitsea has developed methods to visualize software, especially the architecture, dependencies, and design patterns violations. This is like an X-ray of a software system. This helps customers to quickly understand complex software systems and to improve software quality. Early detection of errors helps reducing testing effort, leads to higher maintainability, and finally reduces the total cost of ownership and increases development speed. One part of our audit is the open source assessment. Bitsea uses a multi-factor approach to open source discovery and advises customers on open source obligations and risks. Our customers benefit from sustainable open source security and compliance management. They receive a transparent bill of materials of components, licenses, and license obligations. Our experienced audit team identifies and monitors operational open source risks and helps you ensure source code compliance. Bitsea is part of the open chain community. We help our customers and companies to understand and apply the open chain standard for quality open source compliance programs. We also provide open source compliance trainings. Our customers are mainly international corporations with a big variety of software applications, especially within the car industry, aerospace, defense, logistics, and telecommunications. Let me start with our discoveries. Code travels. And good developers do not write code from scratch. They know where to get code. In a typical software system, you will find fractions of your own code, some code your developers brought in, maybe some commercial libraries, and open source components. All of these components form your product. Improving productivity, shortening time to market, and reducing development costs are all good reasons to reuse, outsource, use open source, and buy commercial software. However, especially the open source does not mean free of license obligations and copyright. Some licenses prohibit commercial use or require that the code is published if it is modified. It is important for you to know all of the components, their licenses, and the obligations to be able to be compliant. What is software composition analysis? It is the process for identifying open source for the purpose of risk management, security, and license compliance. With the rise of open source use in software across all industries, the need to track components increases exponentially to protect companies from issues and open source vulnerabilities. Because the majority of software creation includes open source, manual tracking is difficult, requiring the need to use automation to scan source code, binaries, and dependencies. A typical software systems consist of hundreds of open source components with hundreds of different obligations. To our experience, many developers are not aware of all the open source components that are used to build their systems, mainly because of repository managers bringing in dependencies or big components that themselves consist of many other small components, or components missing a clear license declaration, or binary components are used which do not explicitly show license information. It is important to know all implications to avoid risk and to be able to follow obligations, attributions, or the publication of code, depending on what the license asks for. Today, we will not cover general aspects of open source licensing and risks. You're welcome to watch the recordings of some of our recent webinars covering general aspects. Today, we are doing a deep dive into Linux, its licensing specialities, and findings that we discovered in some recent audits. Linux is very big. A typical distribution will consist of more than 60,000 files. Linux is split up into a kernel space and a user space, as you can see on the picture. Code in the kernel space mainly follows the GPL. If you add code in the kernel space or modify it, it again needs to follow the GPL license. If you add user applications in the user space, which use the official UAPI only, then other licenses can be used. And Linux has many, many contributors with many different licenses, different attributions that need to be mentioned. And in former Linux versions, not each file was clearly marked. This makes it complex to follow all obligations. By default, all files without license information are under the standard license of the kernel, the GPL2 version with Syscall node. Different license terms are often listed directly in the code. The identification of all copyright holders, licenses, and license obligations within a Linux distribution is one of the most complex and tedious auditing activities and may take several weeks. In earlier Linux versions, before version 4.15, many source files lack license information. This makes it difficult for compliance tools to determine the correct license, and a manual check is very time-consuming. On the following slides, I have some examples. In this example, we see a typical Linux file. In the header, you will find the author, the copyright holder, and the license text. Sometimes the license text is listed in a separate copying file, and the header will only reference this license text. The file in this example follows the MIT license. This form of the license listing is very easy to understand for the user, and the user can also easily follow it. But not all licenses are explicitly listed, as you can see in this example. Sometimes you will just find a note that a part of the code was copied from somewhere and a link to where the original is located. This case requires you to look up the original source, its license, and obligations. In the first highlighted section, you see that some code was based on some other code, and you see a link where the original code can be obtained. You can check the copyrights and licenses there. The second case shows a copy from another file, and again, you can look up the original and hopefully identify author, copyright, and license. The next examples are getting more difficult. Sometimes you may not even find the source of the origin. The code may just indicate a name of an author who wrote the original piece of code. This case normally requires to approach the author to clarify the license and to ask for usage permission. Or you may be able to find the original code with a declared license in the internet. And sometimes the code only references a name, which is very difficult to identify, like the latter example, stolen from Wankman. You can try to identify the author by searching the internet, but again, this may be very time-consuming. However, the worst case are files without any information. Neither author nor copyright holder nor license are listed. We will use this file for our example. The user needs to find out who's the author of this file and who is the copyright holder. And there are many possibilities to do so. You can search in repositories in the internet to find the original. Sometimes the file may have been copied without the license header. You may investigate if this file is part of some other open source package. You can use tools to identify code snippets or open source packages, and then hope to be able to find out the license. Nevertheless, it is very time-consuming and very difficult to clarify all license obligations for all files in a Linux distribution. This made usage of Linux more difficult for companies and deterred potential users. This was also realized by the Linux Foundation. So a plan was developed to clearly identify all applicable licenses for all files, to make it easier for users to understand licensing and to be able to be compliant. The cleanup activity worked like the following. All files without a clear license information were supposed to get an SPDX header. If there was no license in the file, by default, these files were put under the default license of the kernel, which is GPL version 2. Files were updated with a GPL2 SPDX license identifier. The SPDX identifier is a legally binding shorthand which can be used instead of the full boilerplate text. The cleanup team claimed to have spent more than 70 hours of work. If you compare this to a full Linux audit, this is very fast. The cleanup team developed an algorithm, which I will briefly describe. Starting point was the Linux kernel 4.13 with around 60,537 files. To determine which SPDX license identifier to apply to a file, two scanners were used, ScanCode and WinDriver. Their results were put in a table side by side. Criteria used to select files for SPDX license identifier tagging was files that had source code, made and config files which had more than 5 lines of source code, or files that already had some variant of license header, even if they were smaller than 5 lines. Then, when both scanners couldn't find any license traces, the file was considered to have no license information in it, and the top-level copying file license applied. If a file had some form of licensing information in it, and it was in the UAPI directory, it was denoted with the Linux syscall node if any GPL family license was found in the file. When the two scanners agreed on the detected licenses, that became the concluded license. When there was disagreement between the two scanners, like one detected a license but the other one didn't, or they both detected different licenses, a manual inspection of the file occurred. So let us see what happened. Let's come back to the file in our example. In version 4.13 of the Linux kernel, it did not show any license. None of the scanners was able to detect a license in the file. So it was concluded that this file has to follow GPL, and in kernel 4.18, you can see the added SPDX header. The file is now licensed under GPL2, as you can see in the picture. However, there was some doubt. All the other files in the directory with the same driver, they were subject to the MIT license. This file was directly included in the other files, all showing the MIT license. And these files technically belonged together. Digging deeper into this, it can be concluded that the file originally belongs to a package licensed under MIT. To summarize, during the license cleanup, this file was marked as GPL2 with the described algorithm. However, close analysis of the other files in the drivers directory indicated that this file is subject to the MIT license. This was also recognized by the Linux Foundation and corrected in a newer version of the kernel. If you look at version 5.6, you can see this file is now showing the correct MIT license. And the commit statement mentions that the GPL header was accidentally added to the file. And now everything is fine. Is it? Imagine you are a customer using a Linux kernel 4.19. So that is a kernel somewhere in between 4.18, where the GPL header was added, and before it was corrected in 5.6. Which license should be assigned to the file? Should the file be in GPL, as it is indicated in the header? Or should it be MIT, as it is corrected in future versions? If you do not look at future versions at all, and just investigate or analyze the file, you will even not be able to see the correction. We had lawyers looking at this case, and according to the lawyers specializing in license compliance, the license cleanup never intended to change the license of the file. This happened because the algorithm used to automatically mark all the source code files in the Linux kernel was not perfect. This leads to the assumption that the license to be followed for this file is MIT and not GPL, even if the header indicates something else. If you use any of the standard scanning tools, they will detect the SPDX header only and will show a GPL license for this file, which we now have learned is wrong. I'll hand over to Michael for the next slides.
Thank you, Andreas. Hi, everyone. So my name is Michael Lelchuk, and I'm a manager of professional services at Revenera. I'd like to start off by talking a little bit about the depth of the analysis and also the potential impact of not analyzing code to a deeper level, not only with respect to the Linux kernel, but for any other third-party packages or libraries. Then I'll touch base on how to detect license inconsistencies and the need to do a deep code scan analysis. I'll also talk a little bit about a few examples we've seen in our previous audits as well. And actually, before I begin, I'd like to say that I'm not a lawyer, and anything I say here shouldn't be taken as a legal advice. So when should you spend more time and effort analyzing for third-party licenses? Well, ideally, you should always know what's in your code. It's always important to analyze your software, detect the use of open source and commercial code in your software, and identify those third-party licenses. Sometimes, though, that's not always possible, perhaps due to a time constraint or a budget or a resource constraint. So I'd like to talk a little bit about a few cases where I think you should spend that extra effort. So anytime you encounter a large package with lots of files, Linux is a great example there, chances are that they're not all licensed under the same license. When you have multiple contributions from various authors to a single package, there's a chance that there will be multiple licenses, and you probably should know what those licenses are. It's definitely a good idea to put that extra effort into open source license detection for code that's part of your distributed product. If your product is SaaS, there are some licenses that you should absolutely be concerned about, like the Athero GPL, the Sleepycat license, maybe GPL, LGPL version 3. But other licenses may or may not be concerned in a SaaS from a compliance perspective. But if your code is part of a distributed product, you should be concerned about everything that's in there. You should know the different packages, different licenses that are present in that code. And lastly, if you're going through an M&A, or maybe you're just trying to prepare third-party notices or attributions report for your product, which is a business reason, you may also want to spend that extra effort to find all those third-party licenses and notices. zlib, for example, zlib is a good example there. Zlib, as you know, is distributed under the zlib license, which is in itself very permissive license, but zlib does have some GPL license code in there. Although that GPL license code has exception, and you're probably okay using zlib, you'd still want to know that information for your third-party notices report. Linux is another great example. So what's the potential impact if you ignore what's inside Linux or inside another third-party package? Well, Andreas just talked about specific license mismatch issue that is present within Linux kernel. So if you ignore what's inside Linux, you'll obviously miss those license inconsistencies. As you know, Linux's kernel is distributed under the terms of the GPL2, but there are actually more code in the kernel itself. There are various third-party subcomponents in there. There are Linux kernel modules. All of these packages may be released under different licenses. There are over 90 different licenses in there, in the Linux kernel specifically. If you're a company that has kernel as part of your shipping product, then you should at least be aware of all those subcomponents and the licenses that are associated with them. Also, each of these packages may contain security vulnerabilities, which would be missed if you ignore the Linux kernel analysis. So how do you detect these inconsistencies or incomplete open source licenses? Well, unfortunately, there isn't any software available today that can scan something and automatically detect it. If you want to be comprehensive in your analysis, you have to go through not only the automated analysis and detection, but also the subsequent manual work to identify these inconsistencies. Sometimes you have to grep or look for a pattern, which software could do for you, but humans are better. Often you see vanity licenses that developers create. These are one-off, very specific one-off licenses. These also need human analysis and human interpretation. Sometimes ambiguity requires you to reach out to the community or to the author to understand the license and the license terms. Or in the case of the Linux kernel, the discussion that Andreas just walked us through, where you look at the files that are located in the same directory, the brother-sister files as we call them, doing that analysis can lead to inconsistent or incomplete open source licensing. The key takeaway here is that the detection of the incomplete and inconsistent licenses is largely a manual effort. Okay? When and why there's a need for deep code scanning. So when it comes to Linux kernel or any other library, it can be a problem if you only concentrate on the main third-party component, its controlling license, and ignore the subcomponents. You have to remember that a supplier to my supplier is also my supplier. And from the compliance perspective, it's important to make sure that all software is distributed properly. Subcomponents are important because they too have licenses. You have to comply with those. They too may have vulnerabilities that you have to comply with. Even doing snippet-level analysis can not only lead you to discovery of the open source packages, but also to the discovery of vulnerabilities as well. So when it's necessary to maintain a full and complete list of software bill of materials and identify the potential security vulnerabilities, the only way to accomplish that is with deep code scan analysis. And also, as I mentioned earlier, to accurately prepare the third-party notices report and attributions report for your company, you will most likely need to do the deep code scan analysis to produce such a report. If it's something you have to get done internally for business reasons, or perhaps your customers or partners request you to provide such a report, that's when you will see the need to do the deep level code scan. And by the way, it's very common now, especially if you're preparing yourself for an M&A or if you're distributing your code downstream to your customers, it's very common to be asked for a comprehensive SBOM along with the third-party notices and attributions report. So it's probably a good idea to be prepared and have it ready, because the chances are you will most likely have to go through this process in the future anyway. And lastly here, I'd like to talk a little bit about some examples of what we've seen in our past audits. So we've seen the obvious, where copyleft licenses found inside of permissively licensed packages. We've seen that. Happens all the time. It's very common to find code from Stack Overflow or Stack Exchange. Unless stated otherwise, the content from these sites is distributed under the Creative Commons Share-alike license, which is very similar to the GPL. Most companies do care about that, and they do remediate the code that's coming from these websites. Also, with respect to the Linux kernel, we've seen developers modifying the kernel, writing their own code, proprietary code, and sticking it into the Linux kernel. However, unaware that the code must be made available to the public if it's part of the shipping product. And this is something that the companies weren't prepared to do. We've seen similar, not just with Linux kernel, but with other packages as well. We've seen proprietary code leaking out into the open source. That's actually very scary. We've worked on a project where a customer asked us to perform the analysis, and we matched the company's commercial code to code found in some other open source package. And we found it using the snippet analysis, and I can tell you that this was a shocking finding for the customer. If they did not perform the deep dive analysis, we wouldn't have found that. And although this is rare, I've seen this a number of times in my career now. We've seen many versions of the same component, some with vulnerabilities. So for example, a customer has 10 different versions of OpenSSL. They were only aware of one, which did not have vulnerabilities. They didn't know about the other 9 versions in there. One or more of those 9 versions had vulnerabilities. And we see this all the time because of the concept of software composition and the reuse of open source. And lastly here, contradictory licenses. Again, this happens when someone who's not a license expert, they add license to his or her code, and the license contradicts itself. So for example, I've seen someone say, the code is placed in the public domain distributed under the terms of the GPL. 2 completely separate licenses found in the file. So these are some of the interesting examples from our past audits that we've encountered, and some of the things to look for during the analysis. Chris?
Thank you, Mike. So what we have learned today is that the automatically inserted Linux SPDX headers are not always reliable, and that a manual post-analysis is often necessary. Code snippets may have been copied, stolen, or lack a license. In the example that we showed, we saw that the correct license is listed in a future version. However, it is very difficult and time-consuming to analyze not only the version that you use, but also all future versions. Most of the time, this is not economically feasible. Michael?
Yes, sorry. And as I've mentioned already, if you ignore Linux kernel analysis, you're basically ignoring all the various subcomponents. So, you're ignoring the subcomponents, the licenses that are in there, and the vulnerabilities that are distributed with Linux kernel. Deep scanning analysis sometimes is also essential, as I mentioned as well. If you want to produce a comprehensive bill of materials, or if you're trying to prepare that third-party notices and third-party attributions report, or if you're trying to identify all the vulnerabilities in your company's code, you should consider the deep code scan analysis. In closing, I'd like to emphasize that the choice of the audit type or how deep you want to analyze largely depends on your company's policies, your business needs. There are also other factors like budget and resources and timeline. Also, managing the risk falls on various people within the organization, not just the developers. There's legal that's involved, executive personnel, open source review board, etc. So you should be having these conversations internally so that you know and you understand the code management strategies and your company's policy. And in the end, it comes down to the risk factor, how much risk your company is willing to take. Thank you.
All right, thank you, Michael. Once again, to our audience, if you would like a copy of the slides that were just presented, you can download them from the drop-down menu on the bottom left-hand side of your screen. Let's move on to the Q&A part of our session now, and I'll read these questions from the audience in no particular order. Our first question here, and I'm going to combine a couple because they seem to be related. How deep in the dependency path should one look when doing analysis? And is deep code scanning analysis the same as forensic level scan and audit?
Michael, do you want to
answer just real quick, the deep level scan is the forensic level analysis.
Okay, and then to the other question you just mentioned, how deep in the dependency path one should look. It really depends on how much risk you want to take. So for sure, if you want to be completely safe, you should look at the full dependency path of all the components. But very often, even a small software product can turn into something very big. When developers include only a couple of packages, there may be so many dependencies and hundreds of thousands of lines of code that are included that nobody is aware of. At the end, you should check what is delivered, what is distributed, and what stays in-house. And especially that part that is distributed, that is the most important part, that is very clean and that you follow all the different license obligations that you have in there. Is there anything you would like to add, Michael?
When we typically have an engagement with customers, we almost always ask for direct dependencies. So direct dependencies are almost always important. The transit dependencies are most secondary, and those depend on, again, time and budget, but direct dependencies are very important.
All right, thank you both, and I'll move on to the next question here. How much effort is a detailed audit of a complete Linux kernel?
I can take that one. The effort depends on the number of files that you want to analyze. And as I mentioned, the Linux distributions are very big. Normally they have around 60,000 files and more. And it depends on how deep you want to look into them. If you just look at the top level critical licenses, or if you want to understand all the copyrights, all the obligations and dependencies, it can easily take several weeks to analyze the full Linux version.
All right, thank you, Andreas. And we'll move on to the next question here. How is deep scanning for IP related to identifying security vulnerabilities?
I'll take that one. This is Michael. So if the company isn't doing deep scanning, then they aren't really fully tracking the use of their open source, and the list of their software bill of materials isn't complete. So if they're unaware of certain packages being used, they're probably also unaware of various security vulnerabilities which may be present in those packages as well.
All right, thank you, Michael. We'll move on to the next question here. Are commercial Linux subscriptions not a way to let corporations like Red Hat or Canonical take care of license concerns on the behalf of the licensees?
I can take that one. So actually, we get this question often from our customers because there is the assumption that when you use Linux distribution, that you're safe with the licenses and somebody else took care of all the license obligations that you have. To our understanding, this is not correct. It is always the software issuer who has to ensure license compliance. All the license obligations, they vary depending on how you build the product and how you use it and what you build out of it, and especially how you publish it. So it always depends on you, and you're responsible to be compliant.
All right, thank you, Andreas. And I have one last question here. What has been the most severe FOSS compliance issue you have seen, and how was it remediated?
I've answered that question in the chat there. The question came from Yari. So we've seen forensic matches. So when we did the deep level scan in our audits, we've seen forensic matches to a GPL licensed components, which were embedded in a core distributed product. And there were a few of these, not just one match, but many. And so what happened in that case, the acquisition just didn't move forward. Again, I'm not sure on the dollar amount, but that's pretty severe when acquisition is not moving forward due to these types of findings.
All right, thank you, Michael, and thank you again for a very informative session. Our speakers today were Andreas Kotulla and Michael Lelchuk, and I'd like to give a special thanks to Revenera and Bitsea for making this webcast possible. Once again, to obtain your CPE credit for this presentation, please disable your pop-up blockers in order to access the exam. The webcast will close automatically, and the final examination will be presented in a separate window. If you have trouble viewing the CPE test or receiving the CPE certificate, please send an email to webcast@complianceweek.com. This webcast has been recorded and will be available later today to Compliance Week members on our website under the Webcast tab, which also contains a library of additional CPE webcasts. If you'd like to learn more about becoming a member, please contact us at info@complianceweek.com. For today only, we invite you to use the code WEBCAST365 to receive a membership for just $1 a day. Check out complianceweek.com/membership to learn more. This concludes our webcast. Thank you again for joining us, and enjoy the rest of your day.